Welcome to Rex. In this video, we'll be learning about how to use Rex to create a box plot. A box plot displays distribution and skewness by grouping numerical data into quartiles. Let's first take a look at our data. Today we are using the Fisher's iris dataset, which is a classic in the field of statistics. The iris dataset contains 4 features: the sepal length, the sepal width, the petal length, and the petal width, for 50 samples each of 3 different iris species. Let's say we want to create a box plot that visualizes the distribution of sepal lengths. In order to do so, we will go to Graphics and click Box Plot. We'll first be using this Variable tab to select the variables to plot and to define the grouping variables. As we can see, the headings in the first row of the Excel datasheet are displayed under All Variables. We can use the arrow buttons to add or remove variables from each option. Let's first create a box plot that shows the distribution of sepal lengths for the entire dataset. In order to do so, we will select sepal length as the variable of interest. Next, we can click OK. In this box plot, we can see the distribution of sepal lengths for all of the iris samples by looking at the minimum, first quartile, median, third quartile, and maximum values. For example, this box plot indicates that the median sepal length is around 5.8 centimeters. We can also see that this box plot is vertical. Let's say we want our next box plot to be horizontal. In order to do so, we go back to Graphics, Box Plot. As we can see, the settings we made for our last box plot are saved. Because of this, sepal length is already set as our variable of interest. We will now go to the Output tab. We can use this tab to customize many parts of our graphs, such as changing the graph style, the legend, and more. In order to change the orientation of the box plot, we will go to Graph Properties, Orientation, and change it from vertical to horizontal. Let's click OK. Now we can see that we have a horizontal box plot, where the sepal length is on the x-axis. Now that we have a good idea about how our variable is distributed for the entire dataset, let's make a box plot that shows the frequency distributions for each species. In order to do so, we go to Graphics, Box Plot. Let's first reset our options to the default, and then we will add sepal length as our variable of interest, and now species as our grouping variable. Let's click OK. In this box plot, we can see that each iris species is plotted separately in a different color. For example, the Setosa species is shown in red. Using this box plot, we are able to compare the distribution of sepal lengths between each species. Now, for our next box plot, let's add some data points on top. We can go to Graphics, Box Plot. As we can see, the settings we made for our last box plot are saved with sepal length as the variable of interest and species as a grouping variable. So in the Output tab, under Include Data Points, we can decide whether or not to include raw or jitter data points on top of the box plot. Today, let's include jitter data points. Let's also check this box to include the mean point. Now, Rex gives us the option to customize the style, size, and the color of our mean point. Today, we will keep our default options of a diamond point with a size of 2.5 and an outline width of 1.5. Finally, let's say we want to make the box width a bit smaller for this plot. To do so, we will change the box width to 0.5. Now we can click OK. In this box plot, we can see the jitter data points as black dots and the mean point as a red diamond. We can also see that our boxes itself are a bit narrower than the previous plots. Next, we can also use Rex to perform statistical tests and output the results with our box plot. Let's say we want to output the results of an ANOVA test To do so, we can go to Graphics, Box Plot. We will keep our variable settings from the previous graph and move to the Output tab. Here, we can now see that the Statistical Test menu is enabled. Note that this menu is enabled only when a grouping variable is selected in the Variable tab. Here, we first decide whether to perform testing assuming that the groups are independent of each other, or to determine whether the groups are related to each other. We can then choose the test method and customize the text size and position for the results. For our data, let's assume that the species are independent of each other, and we will choose parametric to perform an ANOVA test. Finally, let's click OK. Now we can see that the ANOVA p-value is on the top left of our plot. Here, the p-value indicates whether or not the difference in mean values between groups is statistically significant. Notice how the p-value is less than 0.0001 for the differences between mean sepal lengths between each species. This indicates that the mean sepal lengths are statistically different. Now that we have a good idea about how our variable sepal length is distributed for each species, let's say we also want to compare the distribution of sepal widths between each species. In order to do this, we can go to Graphics and Box Plot. Note that I have already reset it to the default options. So now we will put sepal length as our first variable of interest, sepal width as our second variable of interest, and we will click Plot in one window in order to plot both variables in a single graph. Lastly, we will put species as our grouping variable. Now we click OK. Now we can see both the distribution of sepal lengths and sepal widths for each iris species. For example, we are able to see that the Setosa species has the smallest median sepal length and the largest median sepal width. In our final box plot, we will use Rex to add a variety of elements such as a horizontal line, a graph title, and a custom y-axis. Let's first go to Graphics, Box Plot, and reset it to the default options. Now, we will choose sepal length as our variable of interest and species as our grouping variable. Next, we will go to the Add Elements tab. We can use this tab to add straight lines to our graph, and we can customize the line type, properties, positions, and width. Let's say we want to add a reference line that indicates a sepal length of 6.2 centimeters. To do so, we will add a horizontal line and set the y-intercept as 6.2. Next, in order to make a thick dotted line, we will set the width as 1, and we will select the dotted style. Lastly, let's set the color of our line, and today we will set it as pink. Now that we are done customizing our line, we click the arrow button to add it to our plot. Finally, we will go to the Miscellaneous tab. We can use this tab to choose our graph title and to customize and label certain axis values. Under Text Labels, Graph Title, let's name our graph Test. Let's say we want to show that our sepal lengths are in centimeter units. In order to do so, we will add 5 as our y-axis value and enter the label 5 centimeters, and then we will click the arrow button to add it to our label tick values. Now we will repeat this with 6, 7, and 8 centimeters. With this, we are done customizing our graph, and so we click OK. In this box plot, we can see the title that we made for our graph, and we can also see the centimeter labels that we set for our y-axis. Finally, we can easily see a thick pink dotted line at 6.2 centimeters. Overall, as we have seen in this video, we can use Rex to create and customize box plots. Thank you for watching today's video in Graphics in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.